for me to introduce our next session focusing on varieties. Chloe's already touched on variety choice in her presentation there, so it leads on in nicely. I'm going to give the stage over to Paul Gosling. I hope he's here. I had a panic then. Paul heads up the recommended list project run by AHDB, and he's going to be giving us an update of what's going on in the world of the recommended list. Thank you, Paul.
Thank you, Richard, and good afternoon, everybody. I don't have very much time, so I'm not going to go through the new varieties. I'm sure you've all seen the new recommended list. If you haven't, you can look at that at your leisure. I'm going to talk about a few other things related to recommended list. I'm going to start with a little bit of an update with Septoria about what happened last year, what we think is going to happen the coming year. I'm then going to talk about the wheat yellow rust variety watch list, which is something you may not have noticed as produced last year. Then I'm going to finish with a little bit of talk about potential value of BYDV resistance that we're starting to see come into varieties now. So starting with Septoria, 2021, what do we know? What happened? Well, I think we probably all know in this room that winter wheat varieties with the old variety Cougar in their background suffered from higher levels of Septoria than we would have expected from their resistance ratings. And we know from historical work done that Septoria isolates that are virulent on the old variety Cougar around it in the environment. They were collected in 2016 and 17 when that old Cougar variety broke down to Septoria. And they've also been collected in Ireland in 2020 when some of these new varieties started to break down to Septoria. And we also know that those isolates are both widespread and genetically diverse. It's not a single isolate that's evolved resistance to Cougar and then that spread. They're very diverse genetically, so we know they were out there in the environment before Cougar actually went out onto the market. What we also know is those isolates don't seem to be very common in Scotland. In trials this year, we didn't see the breakdown of resistance in those Cougar-related varieties. Or in most of the trials where we did see it, it certainly wasn't to the extent that we saw it further south. One piece of good news, or bad news, depending on how you look at it, is that these isolates that are virulent on these Cougar-related varieties have a similar resistance profile in terms of fungicides. So when you treat them, they'll behave just as you'd expect Septoria to behave in terms of fungicides. And that information was found both in 2016 and 17 when we collected isolates in the UK, and they also found it in Ireland in 2020. So what's going to happen in 2022? Well, trying to predict the future is a bit of a mug's game, but I'll have a go. So we know that all the varieties that have Cougar in the background have not been affected in the same way. Some have seen their ratings fall on the new recommended list by up to 2 units, but some have hardly fallen at all, less than 1 unit. And actually some of the old varieties we've seen this year, their ratings have fallen. So don't treat all the varieties the same. They're certainly not all the same. People tell you you need to look at parentage to understand how varieties will perform. That's true to an extent, but it only tells you part of the picture. We think disease in 2022 will most likely follow the 1-year ratings that we published in the recommended list. If you haven't seen the recommended list yet, we published our normal 3-year ratings. We also published a rating based just on the 2021 data, and that shows them all the effects of this Cougar breakdown. So we think the disease will follow that with 1-year ratings rather than the 3-year ratings. It's not at all clear yet whether these new isolates will appear in Scotland. It may be that they simply don't like cold, wet conditions, which apparently is what it's like in Scotland. It may be that they will spread further north, that simply those varieties with Cougar in the background haven't been grown very much in Scotland, so they haven't really appeared. We'll have to wait and see on that one. And it's interesting that the variety ratings haven't crashed. Yes, one variety has fallen almost 2 units, but some of those varieties with Cougar in the background have fallen less than a unit, and actually some of the other varieties have already said have seen their ratings fall. They haven't crashed because the breeders have actually done a very good job of becoming less reliant on single major genes, and they're incorporating lots of minor genes now, which individually don't do very much, but when they add up, they give you that good background resistance. So the ratings haven't crashed. They've come down around about 1 unit for most of these varieties. If we do see further shifts in Septoria resistance in trials in the coming season, we will let the industry know as soon as we can. Unfortunately, last year, because the Septoria epidemic was very late, by the time we realised that there was something going on, most people had put their T2s on. It was too late to do anything. We did let the industry know, but it was generally too late. If we have a more normal Septoria season with the epidemic developing early in the season, we start to see odd things going on in trials, we will let you know as soon as we can. So that was Septoria. Now I want to move on to the wheat yellow rust variety watch list. Now this is something you may not have noticed sneak out last year. We snuck it out because we didn't know whether it was going to work, which I'll come on to. But we know there is an issue with yellow rust in wheat. We know the yellow rust population is very diverse, it's very dynamic, and that causes us a problem. It means for the breeders that their genetic resistance they spend time incorporated in their varieties can be overcome very quickly. And for us on the recommended list, it means keeping our resistance ratings up with what's going on in the field is very difficult. And we know that in past years, sometimes our ratings haven't reflected what's happening in the field. And that's because our ratings tell us what happened last year. It doesn't tell us what's going to happen in the year ahead, which isn't really very helpful. So in the winter of 2021, we launched the wheat yellow rust variety watch list. It's based on our own data, and the aim of it is to try and highlight varieties that may be vulnerable to falls in resistance in the coming season. As I say, the ratings tell you what happened last year. This is an attempt to try and say what's going to happen in the coming season. It works by looking at the disease levels in the 3 worst trials for each variety relative to the other varieties. So it's not necessarily those trials where a particular variety had the highest levels of yellow rust, it's where it had the highest levels of yellow rust relative to the other varieties. And it uses those 3 worst trials to try and produce a new rating, and we use that new rating to produce a scale. That scale goes from what we call the most resistant, and that is varieties which are resistant to yellow rust in all the trials. Even if we pick the 3 trials where they did the worst, they still perform really well, just as you'd expect. And it goes from there to least resistant, and that is varieties which are highly susceptible to yellow rust in at least some trials. There's still those varieties with things like Skyfall that are susceptible to yellow rust everywhere, but there will also include some varieties that are generally pretty resistant, but starting to look a little bit susceptible in some areas, in some trials. The advice we issued at the time was to monitor the least resistant varieties on that scale frequently, probably more frequently than you would do normally, and be prepared to increase your rust-active fungicide program on those varieties. So did it work? I said it was experimental, which is why we didn't have a big fanfare. But the chart on the left-hand side of your screen, what it shows is on the scale on the y-axis, it shows the difference in the resistance rating on the current list, the one that's just been published, compared to last year. So if it's a negative number, the new rating on the new list has gone down. If it's a positive number, the rating on the new list has gone up. And on the x-axis, what it shows is the order on that watch list. So on the left-hand side, we've got the most resistant varieties, the ones that we predicted would have a stable yellow rust rating. And the ones on the right-hand side, the ones we said were least resistant, the ones that we thought might be starting to have issues. Now, I'm not going to try and suggest it's a perfect relationship, but there is a general pattern going on here where the varieties we predicted would be that would be the most resistant to falls in their resistance rating have remained fairly stable. There is one outlier, RGT illustrious, don't know what happened there, but generally speaking, those that we predicted would be most resistant have maintained a fairly stable yellow rust rating. Whereas the ones that we predicted would be least resistant, yes, some haven't moved, but this is where we find the ones that have, or some of the ones that have fallen up to a unit in their resistance rating. So it looks as if this is a reasonable way of predicting varieties that may be vulnerable to having their ratings fall. Big caveat, it's 1 year's data. It may be that if I'm standing up here next year, this relationship is broken down completely. But based on 1 year's data, this does look like it's a possible way of predicting which varieties are going to have their ratings fall, the ones that you need to be monitoring a little bit more. We will be producing a new rust watch list in January, so keep a lookout for that. We'll see after 2 years of data, see if it's still holding up as well. And I want to mention a little bit about BYDV, resistance and tolerance. And what is its value? Okay, we know it's there now. We've got 1 wheat variety which is resistant to BYDV in Wolverine, and we've got BYDV tolerant varieties. We've had those around a couple of years now. We've got the first one on the recommended list this year, KWS Fearless. But what difference do these varieties actually make in the field? We know pyrethroids are cheap, and generally speaking, we don't have much of a resistance issue in cereal aphids. So is it a useful trait, or is it just a gimmick? Now, I'm sure most of you, if not everyone in this room, will have been involved in trials work at some point. Sometimes trials work, sometimes trials don't work. But sometimes when they don't work, you get interesting results. And this is a good example of that. So last year in the recommended list, we had 2 RL winter barley trials in Dorset. Well, they ended up being only 1.5 kilometres apart. That was not by design. They were different trial operators. Those different trial operators decided to place those trials in particular places, and they happen to be quite close together. Ordinarily, that wouldn't be very good for us. But in this situation, it worked out quite nicely. So they were close together in terms of location, and they were drilled just 10 days apart, one on the 15th of September, one on the 25th of September. So close together and drilled at a relatively similar time. The earlier drilled trial received a pyrethroid, lambda-cyhalothrin, on the 11th of November. The other trial did not. And what we found in the spring was the later drilled trial developed quite clear BYDV symptoms. The trial that had the pyrethroid didn't develop any BYDV symptoms. And I apologise for the quality of these photos. They're not the best photos in the world, but hopefully you'll get a bit of an idea of what happened to those trials. So this is the trial which did get BYDV symptoms, taken in the spring. What we have on the left-hand side is 2 varieties in that trial. They're all the same varieties in the 2 trials, which had developed clear BYDV symptoms. The 2 pictures on the left are the 2 varieties in that trial, KWS Fearless and another variety, which claimed to have BYDV tolerance, and there was little, if no, BYDV symptoms in those 2 varieties. So symptoms-wise, it looked like the tolerance is doing something useful. But of course, the thing that really counts is, does it actually have an impact on yield? So these are results of those 2 trials. Across the bottom, we have the varieties, and on the x-axis, so the y-axis, we have the yield of each of those varieties as a percentage of the trial control. The trials actually yielded, on average, very similar. In the green bars, we have trial EN619. That was the one that developed no BYDV symptoms. And the blue bars, EN614, that is the trial which developed BYDV symptoms. Can you guess which varieties were the BYDV tolerant varieties in the blue bars? No prizes for guessing. They were the 2 highest yielding varieties. If we look at that in a little bit more detail, the trial EN619T, the one which had no BYDV symptoms. So if you take the trial mean as 100%, well then the BYDV tolerant variety 1 had a yield of 108% in that trial, and the variety 2, 103% in that trial. So they were yielding higher than the trial average, and that's probably what you'd expect because they're newer varieties. But if we look at the trial which did develop symptoms, again, we look at it as a percentage of the trial mean of 100%. Variety 1 yielded 131% of the trial mean, and variety 2 yielded 124% of the trial mean. Look at it another way, the BYDV tolerance in variety 1 gave an extra 23% yield, and in variety 2 it gave an extra 21% yield. So we looked from this one piece of information that BYDV tolerance is certainly a useful trait to have. Is this a representative trial of what's going to happen everywhere? Of course it isn't. It was Dorset. We had BYDV in the trial. This isn't going to be a result that's going to be replicated everywhere, but certainly in areas where BYDV is a serious threat, it does look as if this trait is useful. Finally, an appeal. Recommended list works on crop committees. Crop committees select the varieties to go onto the list. They select how the varieties are chosen, and the process by choosing them. And those crop committees, growers and agronomists on those committees. We have vacancies currently on those committees. So if you are an agronomist, are interested in varieties, interested in how the recommended list works, interested in steering the recommended list and selecting varieties, I'd be very interested to hear from you. If you have clients who are very interested in varieties, I'd be very interested in hearing from those clients as well. Committees meet 3 times a year, and if you are interested, please contact me by email or phone number, or speak to me today. We'll close those openings in January, and we have a very informal interview process if we get lots of applicants. But we do have quite a number of vacancies on the committees this year, so please do get in contact if you're interested. Finally, just thank you to the recommended list team, and also to BSPB, MAGB, and UK Flower Millers, who make a big in-kind contribution to the production of the recommended list. Thank you.
Thank you, Paul. With a diminishing toolbox available to us, we're seeing a resurgence of growers looking to using variety blends in an effort to make a more profitable crop. And so on the back of that, I'm going to lead into my colleague, Bastian Brack, who's a crop protection system scientist at AHDB. And he's going to talk us through a tool which he's developed, which brings in different points of data to help growers choose which variety blends that they should use in their farm. Thank you, Bastian.
Thank you, Richard. Yes, so over the next 15 minutes, I want to talk about a collaborative project that took place over the course of the summer. So I worked with a group of farmers and others interested in variety mixtures, and most of them had already started doing their own trials on farm. I picked up that effectively there was an interest, and I wondered if we could do something, produce a tool. Just to say that questions about variety mixes are nothing new. Back in the 60s, I think scientists really started putting their efforts in that question, and that led to kind of a peak in the 80s. But actually, mixtures weren't really taken up by farmers, and so the research declined. But it's kind of come back, and here you see an example of an article published in Farmers Weekly last year, and that was largely based on research coming out of Denmark. And the reason why that research was there was because the Danish RL has included a variety mixture since '95, so really useful, long time series. So this article by Rose Christoffersen looked at particularly the yields, got some really interesting results out of that, particularly that yield was increased overall by about 1 to 2% on average, and Septoria decreased. There's a nice link to what Neil presented this morning in his variety toolbox, where he, I don't know, perhaps you didn't pick it up, but he had the example of Septoria, and variety mixtures was actually one of the items that were identified where the current use was ticked as a 1, but the potential use is a 3. And this research coming out of Denmark really has proven that. So some of the principles underlying why mixtures work are here. And because I'm not a pathologist, I'm not going to go through that in detail, but for me, the ones that are really intuitive are the ones that I've highlighted in blue. So B is the barrier effect, so that's highlighted here. So it's effectively, if you have a mixture where one of the varieties is resistant, and if you've done proper mixing, then that means that, let's say you've got a highly resistant variety and then Septoria comes into the crop, then there is a barrier. So the spores are not being transmitted as easily from plant to plant because of that. So that's one of the principles. And then the other one that I wanted to highlight is the one about compensation. So you can imagine that if you've got a mixture of varieties where one variety, for whatever reason, doesn't perform as well, if it is surrounded by other individuals from other varieties that have basically more tolerance to whether it's drought, whether it's disease, then the available space can be utilized by the individuals of the other varieties. So to me, these two are very intuitive principles why mixtures might work. So then going back to the Danish data, so the data that Rose presented was, I think, included just 2017, so there's some more data now available. So what I did here is I just plotted it. So every year, so let's say 2021, we'll have 4 varieties. So each blue bar is a straight variety. The amber bar is the blend mean. Is the blend, whereas the green one is the mean of the variety. So what we're interested in is to see if the blend performs better than the mean of the variety. So every time where the blend is on the left-hand side, so we're looking at ranked from high to low, every time the blend is on the left-hand side of the variety mean, then effectively the blend outperforms the mean of the variety. So we can see that out of the 27 years of data, that happened in 25 years. So these are the average of 9 locations. The other thing that's interesting to note is something that I was told by a Danish researcher, is that even though this research only started all the way back to 95, it took until basically the last couple of years for wheat blends to be taken up on farm. And her explanation was that, so whilst this evidence base was building up, there were barriers that had to be broken down other than just the evidence. So they had a big workshop where everyone came together, but it seems to be a combination of familiarity with the evidence, as well as the withdrawal of chemical tools. So they increased their use of blends. Actually, in the last year, they had 6 blends rather than previously just 1. Here, I've plotted it slightly differently, but just to say that, so they had 9 locations and 6 blends. 1 was not complete data, but so if we look at the 5 blends times 9 locations, you've got 45 trials, and in 33 out of those 45 trials, the blend outperformed the variety mean. And for some blends, so let's say this one, Nordic Seed Wheat Power Mix, the blend outperformed all the varieties in 3 of the 9 locations, whereas this blend actually didn't. So there is differences from one blend to the other. So what makes a good blend? This is a really complicated question. It's not easy to come up with a framework to make those predictions, but there are some general principles. It depends on the end use. More or less, if you've got 3 or more varieties, that research seems to suggest that works best, but I think I'm going to get a caveat from Ambro later that not necessarily always. So the other important aspect is to choose varieties that have complementary traits. And this goes back to the compensation effect that I discussed earlier. And something interesting, I don't know to what extent this is valid everywhere, so the crudely mixed blends appear to work better than perfectly mixed blends. That seemed to suggest that the barrier effects, in other words, to contain disease, is mostly effective rather than the compensation. In terms of helping farmers choose blends, what data did they use? How did they come to the conclusion? One, I found out quite quickly that they are using recommended list data. But in the same situation that we were 5 years ago when we were thinking about the variety selection tool, there's a lot of data and we need something to sift through all of that. And then, to be fair, my view was just on the RR data, but very quickly I was being told that they wanted to have more information, and I think this came back to what Paul was saying around Cougar. So there was a very strong interest in knowing what kind of parentage varieties are. So these are then the ingredients. So that led to the development of a tool where every possible blend of the available varieties is characterized by two metrics. So metric 1 is effectively an aggregate of the recommended list data, and metric 2 is a parental diversity score. So the higher the parental diversity, so a parental diversity score of 1 basically means that all the varieties in that mixture are not related, at least 4 levels deep, so parents, grandparents, etc. So I'm going to skip these for now. So if you go to the variety blend selection tool on the AHDB website, this will be the first page that you see. So this effectively assumes that you haven't got any preconceived notion about what to start with. So then it is relevant to look at individual varieties. So this is a table. Green circles effectively mean that that variety is in the top third for that particular characteristic. So in this case, we see Septoria here. So Extase, you see here, is in the top third, whereas let's say Detroit is in the bottom third. So that helps clarify the strengths and weaknesses of individual varieties. So this can then, you can then effectively take 1 or 2 varieties, you select them in this drop down, then you click either a 3-way or a 4-way blend, so it takes these varieties and then combines it with all the other possible varieties. So I'll go back. Then it displays that data in this table. So here you can see every combination of the varieties. So we've limited the selection of varieties to those varieties that are on the list, decided eventually to not include other varieties. And here you can see those scores plot against each other. So on the x-axis you see metric 1, which is about the RL data, whereas the metric 2 is the parental diversity score. So the varieties that are at the top with the 1, effectively that means that none of the 4 varieties have a related parent. So just to explain this, here you can narrow down the varieties. So for example, if you want to have at least 3 varieties, say, that have orange wheat blossomate resistance, you can do that, etc. The metric 1 score here, you can effectively create multiple components, so not just one. So let's say if you find Septoria as well as lodging of relevance to your mix, then you can select both of them. That will then be taken account of in the metric 1 score. There are some important caveats. Paul already mentioned one around Cougar. So just knowing that Cougar is a parent doesn't necessarily mean that it's equally susceptible to, say, the Cougar resistance issue. So that's a big caveat around metric 1. And then perhaps an even bigger one is around the use of metric 1, because after all, this data is all coming from trials where varieties are grown individually as straight varieties, and therefore it has not had the dynamics that happen in mixture, so it is not being captured, and therefore the potential of this metric 1 score to really predict how well a mixture is going to perform is limited. So basically where we pitch this is that it gives some inspiration for further on-farm testing. I'll skip that one, and what I want to say is that it is available on the AHDB website. This link I'll probably not bother because I haven't got the time to do the demo further, so I'll leave it at that.
Thank you, Bastian, and we'll have you up at the end for a panel session for any questions. I'm going to go straight into our next speaker, Ambrosio Constanzo, who's the Deputy Head of Research at the Organic Research Centre, carrying on the theme of variety choice. We're talking about Live Wheat, which is the farm-based organic variety trials network. Thank you very much.
Good afternoon, everyone. So yes, very briefly, thanks for Emily and organization for inviting me the second time to the conference and talking about this project. So we're changing a little bit the environment here because we're talking of a project that since for the third year now, and actually is 5 years in a row, we're trying to understand organic wheat. And this is mostly for two reasons. First, because organic wheat as an organic crop was almost disappearing. So the acreage just halved over a decade. And this is telling us something that we need to look at, because this leads me to the second, is if we understand how organic wheat works and how to improve its performance, we may be of help for the whole of the wheat production industry, because we understand how to grow wheat in the absence of external inputs. What is live wheat then is, first of all, a network of farmers. So this project, the initiative of this project is lost. We don't know whether it was an idea from us or from the farmers, but ultimately we got a network of 20 farms. Not all of them have participated in all years. And as you see, there are both organic certified farms and conventional farms with very minimal use of inputs. Some of those who are quite forward on the regenerative journey on no-till and very minimal use of fungicides, etc. So a network of farmers first. Second is a representative array of varieties, and here an important remark: this is not aiming to be a substitute for the recommended list. It's not aiming to give recommendation of which variety to use. It's about asking how far we can get with the genetic diversity that we have available on the market. And for that, we try to diversify as much as possible the varieties we had. And we have, of course, varieties from the recommended list, including a common control varieties that is KWS Siskin, Group 2 benchmark, varieties representative of all end-use classes, and we included also varieties that are not in the RL, so varieties from overseas, German EWIs, which are the equivalent Group 1, as well as some Swedish cultivars. We also included comparison between historic and modern varieties. For example, Mariswegian has been a constant presence across 4 out of 5 years. And also pure line mixtures and populations, and the mixtures now link very well with the work that Bastian has done in parallel during this year. So we are getting to the same endpoint from two different starting points. And populations, so we have the YQ CCP, also known as ORC Wakeling's population, which is actually the progeny of 20 parentals crossed, every one with every other one, and creating something that is completely non-uniform, in which virtually every plant is different from any other, and is supposed to evolve year on year. So, as I said, it was a deeply collaborative work. I'm not going to go in the details of the schedule of work, but the three key protagonists are the farmers, the research team, and the organic arable team. These are a cooperative of grain traders that actually have 70 or more members in the organic arable farmers. And what is important here is to know that we take a lot of data in the field, and especially one of the things that is mostly neglected outside of the organic certification world, which is the wheat communities at different stages during the crops. And another thing to understand the project is about the experimental design. So these are not plot trials. These are trials that are done at a field scale. And what a field looks like in one of the farms, these are just examples, is, for example, a full field of a variety with 3 strips or tram lines of other different varieties with one variety replicated. They can be like this, they can be like that. And generally, it's an incomplete block design. So we test, for example, 15 varieties, and every farm has a subset of them, because having all of them would become unmanageable. And with a bit of statistics, we make sense of all this. The work has gone through two phases. The first one, the first 2 years, it was more about building sort of a theory. And the second phase, which is now ongoing, is about challenging it, improving it. And the first phase is now also published in a paper that is open access, and I can provide references for whoever needs it. So, results from the first phase. I'm going to go very quickly in terms of genetics, environment, and management. I know it's very schematic, but it does make sense. So, on this side, here you see the classic yield and protein trade-off. And basically, what we know about this chart is that it's very easy to go along the line, so increasing the yield by lowering the protein and vice versa. But what the big challenge is trying to go northeast. And on this side, we have the abundance of weeds. Visualize that cover of weeds at the flowering stage of the crop in this case. And we see that there is quite an important difference in terms of varieties. These are the means averaged by farms and years. And that's the nice thing. The two varieties that are northeast of the line, so the so-called grain protein deviations, in this case it's Mariswegian and YQ-CCP, are the same two varieties that have scored the lowest with abundance at flowering. And they are both historic variety Mariswegian and looks like a historic variety also the YQ-CCP because it has many historic parents, including Mariswegian. Second set of results, trying to go very quickly, genetics by environment. So how do we make sense of a series of farms, here there were 11 the first 2 years, where the cover of weeds goes from 5% of soil covered up to 50% or more of soil covered? Is by trying and breaking these averages into a chart like that. So on the horizontal, you have the environmental mean of weeds. So you can move from low weed farms to high weed farms. And then on the vertical, you have the weed cover by each variety. So you see that if we are on a farm with around the 20% expected cover of weeds, it's not that important to choose varieties considering the weeds. But as long as you move to farms where you know that you're going to have a higher weed pressure, that's where it becomes important. And that's where you see that, for example, YQ-CCP here tends to have much less weed compared to others as the weed pressure increases. And you see that other varieties like Evolution instead tends to have more weed than the average. And this is one of the most famous pictures of the live weed project by one of our farmers who showed what a variety can make in terms of weed pressure. Very quickly, the third result, there is also management there. I'm going to go quickly because it is about variety, the session. But generally what we saw is that if we average year and farm and variety, the big driver of differences in yield is the weed cover at anthesis. So the more the weeds, the lower the yield. And organic farmers manage weeds in two different ways. One is a classic narrow rows drilling crop and using a springtime harrow. And the other one is drilling the crop in wide rows and with an inter-row hoeing. And we saw that this also has an effect on the weeds. So mainly the farmers who use the inter-row hoe managed to have significantly less weeds than the farmers who use the springtime harrow. But by having less weeds, they also have less diverse weed community because it's much more probable to have an individual species that is dominating. And I'm going to show you this quickly later. If we go to phase 2, now we go from published results to very interim results. So take them with a pinch of salt, but it's I think it's very important to give you the insights of what's going on. So genetics again, different set of varieties. And we see again the yield and protein trade-off. And we confirm, yes, Mariswegian and the YQ-CCP are still northeast of the line. So seems to have more protein than their yield would predict. But the new addition, and here we comes to Bastian's work as well, is this siskinestase mixture. Two varieties that I'll tell, if you're interested, why we chose to make this mixture over 4 farms. And this is not outperforming the average of the 2 varieties. It's outperforming both of the 2 varieties. And if you look at nitrogen harvest, so actually yield times protein, if you wish, is significantly outperforming siskin as well. And this was significant in 4 farms out of 4 where the comparison was tested. Genetics by environment. Let's look again at these so-called dynamic stability charts. So the grain yield of siskin control variety on the horizontal and the grain yield of the different varieties on the vertical. And we see that the siskin extase mixtures has a flatter line, has a flatter slope than siskin and other varieties, meaning that when yield potential gets lower, the difference between the siskin extase mixture and the mean tends to get higher. This is more stable. Similar things on grain protein. Here we see that the line is very flat for siskin extase mixture as well as for extase variety compared to other varieties and to siskin. So when protein tends to get lower, environment-wise, these two cultivars and the mixture tend to keep the same protein level. This, of course, may well be true even if you go higher in protein levels. So weeds, we were saying weeds were very important, and we looked straight to the dynamic stability charts. Challenging the results from the first phase, we are assessing weeds at 2 stages, so at the onset of stem extension and at flowering. And we see that there are actually 2 mechanisms to reduce weed abundance. So one is what we already seen. If we look at weeds at flowering, we see that Mariswegian in this case, so historic varieties are the ones who are better performing in terms of weed suppression. But if we look at weeds at growth stage 32, so in early spring, we see that Mariswegian is not that much different from average, but who is different was extase in our case. So these are 2 different mechanisms. So one is the growth rate between emergence and stem extension, so the early vigor, if you wish. And the other one is the growth rate between stem extension and anthesis. Both tend to reduce the weeds. Which of the 2 is more important? We're hoping to understand it this year, which has just started. Very quickly, management, we have added more management variables. So we know we have also chemical management of weeds in the equation here. We have the hoeing, we have the springtime harrowing, and we also a couple of farms that actually do no management at all on the weeds. We see that the abundance of weeds doesn't really change. You can have 0 weeds in a herbicide using farm, but you can also have the same amount of weeds as the weediest organic farm. So you can't really say that herbicides do make a change. Of course, one needs to go and look how they are used. The point is that whilst you may not change the amount of weeds, you can change the diversity quite significantly. This is the index of Shannon, so the highest, the more diverse the weed community. And we see that, of course, chemical weed management tends to show the lowest diversity, whereas the highest diversity is in the farms that employ springtime harrowing, and also the relative abundance of the main weed, so how much one individual species is dominant, tends to be highest in chemically managed fields, and tends to be lowest in springtime harrowed fields. And interestingly, farms who employ inter-row hoeing tends to have the same statistically, be more similar to farms who use herbicides than not. And last slide, who are these weeds then? We see that the top 3 are wild oats, very prevalent in as a dominant weed in farms who use inter-row hoeing. Similarly, Italian ryegrass, and blackgrass is quite well spread between conventional organic farms. We see, for example, that farms who use no weed management at all tend to have more prevalence of meadow grasses, which is notoriously not a dangerous weeds. And this is where we have got so far, and we'll see what the conclusions are. But the idea is, what if we concluded that we could help farmers choose varieties based on what kind of weeds you have in your field? What if we prove that Mariswegian work actually better? And what if we prove that we can stabilize and increase yields by mixing 2 varieties that are not different in disease resistance, but different perhaps in growth cycle, so that we add a 3rd component from compensation and avoidance. We also add the complementation. So they just complement each other and maximize the input. Thanks for your attention. I hope I've not been too long.
Thank you, Ambrosia. It gives me great pleasure to introduce our final speaker slot of this variety session. It's Anissa Aubin, who's a AHDB-sponsored PhD student from the University of Sussex. Anissa's been running us through selection of wheat cultivars in UK conditions and the potential climate scenarios. We're very proud to have you here today, Anissa, and thank you very much.
Thank you. Yes, so I am going to talk about the work that I'm doing, and I'm working on some models, and those models are specific to each variety, and then we can use those models to infer how those varieties are going to predict in future climates. So a little bit about me. I grew up on farms in Africa and Canada, and I've been here for about 5 years now, and I work with Agrometrics now part-time. I've been doing this AHDB-funded PhD for a year now. And why wheat? Because it's deemed the most important crop in the UK. So the challenge I was trying to think about, what we're trying to do, is to decide, how do you decide which variety to invest in? How do you quantify the pros and cons of those different varieties? I think there's been lots of discussion of how you do that. Do you use the recommended list? Do you use your historic experience in specific locations? So what I thought I want to do is really to find the varieties that maximize resilience to climate change, many common themes I've seen throughout the talks, while also minimizing risk to food insecurities. Is this what you agree, or at a high level? I'd be interested to know. I don't really need to talk much about the variety and the variation in the climate, because I've heard lots about that, but lots of extreme events, the storm Arwen, these extra wet seasons, and the dry 2018, the average temperatures going up, and like everyone else has said, this all affects yield. So what can we do about it? Create a model, and that can help us understand this current situation. I'm using a model that is based, it's an empirical-based model, so it's based on data, so that we can understand relationship between climate and yield, as opposed to a process-based model where you use your scientific understanding of how one impacts the other, like a photosynthesis type model. And so that's not what I'm doing. I'm literally looking at the data and then creating the relationship. And then we can use that to inform decisions that we're going to make going forward for our future. So for all models, it's the data that we put in creates the validation of the results that come out, and it defines how good the model can be. So I'm going to talk a bit about the data that I have first. So I'm using data from the AHDB trials, and here I've just got a distribution of the yields. So for each year, this is for all the varieties together. These plots widen with the volume, and the dot in the middle is the mean, and then your maximum and your minimum. So you can see that 2015 was a very high yielding year, and your 2012, the average was quite low compared to the other years. So hopefully this resonates with what you've seen. So a bit about my data. I have 25,000 records. So a record is for a single location, for a single year, and for a single cultivar. Information about the sowing and the harvesting. I have over 214 varieties that I'm looking at, over 42 counties, and over those 16 years. Currently, I'm only showing you the data in what I'm going to show you up to 2017. I'm working on getting more current data, but we'll just add that to the model when we get there. So as well as the AHDB trials data, then I'm also incorporating climate data. So I'm using data from the Met Office, and then just to kind of help you visualize this, I've picked this field here, just a field in Reading, just because that's where I'm from. Where I'm saying field, I actually mean a 1 kilometer by 1 kilometer grid. And then for that field, this again, along the bottom, I've got the date, January to December, and then I've got sunshine, rain, and temperature, I'm going to call it, but growing degree days. And I'm going to use each of these as my parameters for the model. So we've got the values from each day added up and then aggregated to the month, and then I've come up with an annual total, and I've done that for all three. And this is really just a visualization. In the model, it goes from the sowing date to the harvest date, so not the whole year like I've got here. And then the reason I use growing degree days is because each extra parameter that I have here makes my model more complex, and that's quite difficult to deal with. So growing degree days takes into account the maximum temperature and the minimum temperature for each day, for each location, for each cultivar, for all the data points that I have. So yeah, all models use assumptions, and the biggest assumption I've made is that the relationship fits a Gaussian function, and so that's a bell curve. and for each variety that I'm looking at. And so that means that as you plot the data points that I have and I try and fit them to this curve, it's going to look something like this. And they're going to be, the optimum value of the yield is going to be at this peak. This is just a one-dimension one. It's kind of difficult to picture it for the 3 dimensions, so the sunshine, rainfall, and temperature that I'm working with. And so those are, the other assumption I've made is that those parameters, sunshine, temperature, and rainfall, are the kind of dominant parameters that I'm looking at. I'm not considering anything else like management practices, soil types, pests and diseases, anything else at this point. So this is a schematic of the whole, sort of like the whole work through of the model. Like I say, I've got the trials data that I'm working with. So I take 70% for each cultivar. This is just making, let's say, one model. So I'll take 70% of that data, input it with some knowledge just to kind of help the model learn that relationship, and also the historic weather from the Met Office. And then we'll get this function. So this is like that Gaussian that I showed you before, but 2 of them put together. So it's kind of looking down on the top of that bell curve. And then with that model, so that will give you a way to say, well, you've got your input climate variables with that model. And then you can, then I'll predict what the yield value will be for that 30% that I've held back, and then compare it. So when I get a good estimation with the prediction as the 30% that I've held back, then I know that I've got a model that I'm happy with. And when we've got that, then we can do some scenarios to create to have a look at future climates and understand, understand how the different varieties are going to fare with that. So the Gaussian model, so I've done here is try to help visualize that 3D plot, like I say. So these are the 1 dimensions I've got for each sunshine, rainfall, and the growing degree days. And we've got yield going up the side, and then just the accumulated value for the growing season. So I think the maximum GDD is about 2,000 there, and the rainfall, about 1,000 and 1,000, I think, for the sunshine and rain. And so that's, suggests that as your growing degree day units go up, at some point you get to a maximum yield value, and then it will drop off beyond that point. This is, again, like I say, based from the data. So here it kind of suggests that you could have 0 rain and you would still have yield, which we know is not possible. It's one of the things I'm going to work with and see maybe about changing it from a Gaussian model. And then so visualizing it here, so this is growing degree days along the bottom and sunshine up the side. And then the coloring is the optimum yield value. So your optimum yield value is going to be somewhere here in that bright light color. And then as you move in any direction, so you could take your field, and so I have my field in Reading, which has, somewhere like 1,000 and 1,000, and its value would be somewhere along here. And so what I did here was for that field in Reading, just hypothetically for 2018, I have predicted using a different model and those values that came from the rainfall, sunshine, and precipitation, put that into my different models for the different varieties, and you can see that it gives me like a variation in yield according to how it thinks the climates respond to those weather input variables. So that's what I've done with the model. This, again, is just looking at a single variety. And so I've got, again, 2017 data, and this is just to show you kind of, it was overall average rainfall, but a lot of the brown suggesting below average in these areas. And then I've done 2 different predictions of what, after learning the relationship between these cultivars, I've got just done KWS Beryl and Crusoe. This is what I would have predicted given what the weather was in those years. Obviously, I'm kind of doing it retrospectively. But once I've done that, so that was just kind of looking at the individual cultivars and individual years. Then I'm looking at potential shift in the climate change. So I've got one scenario here on the left is a much wetter year. And then that, again, the coloring suggests the yield. So this light color in East Anglia is maybe like a 12 to 14 tons per hectare. And this is in a wetter scenario, wetter than what we've had. And then this is in a hotter and drier scenario. And you can see that East Anglia yields now is much, much worse. And so, yeah, we can just look at more different scenarios and understand which cultivars more resilient, and what we can do about that. So there's, like I say, I'm just my first year through, and there's still lots of things I want to do. But in summary, changing some of the parameters or changing the way the model's set up. But so far, I do have the relationship created between the yields and or between the data that I have and the weather variables. And then I will just go on to explore that space a bit more. So I'd be interested to know what agronomists would want to see from this. Thank you.
If I could ask all our speakers to join us on the panel, please, and we'll go to the questions. All right, here we go. Why were Cougar virulent isolates issues? You say that was meant to be issues of Septoria less common in Scotland in 2021? Is the past an accurate reflection of future risk profile for specific geographical areas of the UK? Paul.
I think I said in my talk that we don't really know why those Cougar virulent isolates weren't more common in Scotland. It may be that they don't like cold, wet conditions. It may be that those Cougar-related varieties haven't been grown very much in Scotland, so those isolates haven't had the chance to multiply. What will happen in 2022? I honestly can't say. It will depend on why they weren't there in 2021. We could see them spread up into Scotland and become common. They may remain rare. It's impossible to say at this stage, unfortunately.
Continuing on that Scotland theme then, Paul, should Scotland revert to its own recommended list? For example, KWS state that Xtase should not be grown north of the Tweed due to ear sterility issues. What are your thoughts?
There is a Scottish list produced by SIUC, which doesn't include all the recommended varieties as you'd expect, because not all of them are suitable for growing in the north. So that list does exist. Yes, there can be issues with things like sterility in the north. Unfortunately, we don't always pick that up in the recommended list because, as you can imagine, air sterility is dependent very much on the particular conditions at the time of flowering. So it's one of those parameters that we find very difficult to pick up in the recommended list. But clearly, KWS knew that variety wasn't suitable for growing in the north because of that reason. And Graham is another variety where it has issues with air sterility in the north, so you don't really want to go Graham in the north.
Bastian or Paul, do you think there'll be any resistance to blends from end users?
So this is not an area that I'm usually experienced about, but from hearing from the farmers, they have noticed that is a barrier, particularly for the group 1 and 2 varieties. Feed wheat, not so much, but Paul, you probably know a bit more about that as well.
How close do ripening scores need to be when choosing a blend?
That's another contentious one. So traditionally, what I've seen is that you shouldn't pick varieties with maturity scores that are too different. But then again, other people have been saying that in a blend, varieties do tend to converge, and therefore probably not the most extreme ones, but not as tight. So it doesn't necessarily have to be, let's say, exactly the same maturity score, because there is some convergence when varieties are grown together.
Can I add something? That on the Siskin Xtase mixture that we tasted, and of course, I repeat, it's only 1 year, but they were deliberately chosen to have 2 different growth cycles and different maturity dates. And we are thinking that probably the response for this outperformance may be right there into different stages where they have maximum requirements that do not overlap. So yes, depending on the condition, it may even be a good thing to take 2 varieties with different growth cycles, but we will prove it.
Is there a danger that variety blends accelerate the breakdown of resistance in the resistant varieties in the blend by providing a large source of inoculum from the susceptible varieties in the blend? It's like a tongue twister.
It is being proven and suggested by some researchers in the past that we can create super-resistant strains of pathogens. And one of the things, don't know, Bastian, maybe you will know more about that, but we don't need to only look at the field. Sometimes it's also about the diversity of varieties in the landscape that makes a lot of difference, and how much the same crop is cultivated over a rotation. So ultimately the key is diversity at all levels. Even diversity at only one level is not enough diverse to keep us safe, I would say that.
Bastian, does the variety blend selection tool have a regional variance option built in?
In the sense that different varieties perform better in different regions, not at the moment. What we could do, so on the first page, currently, I think yield is given, so basically the whole UK average yield, but if that was supplied by region, then you could simply sort the varieties by yield for that particular region, which gives you an idea of the strongest varieties for that region. So that would basically be the solution, to add one more column. I didn't initially because there were already enough information, and of course then you need to scroll, which is another disadvantage, but theoretically, yes.
Can you home save a blend mix? And if so, how do the royalty payments feature?
My understanding is that yes, so again, this kind of, because I'm only the developer, it kind of builds on what I've picked up from the discussions the farmers had. So there was this one farmer who had been using a blend for a couple of years, and there's an old variety in there that is no longer, he doesn't have to pay royalties on that one. But for the other three varieties, it does fall within that period. So he's effectively paying royalties on the percentage of the blend. So he had the blend tested. I think was 63% of the blend was consistent of varieties over which he had to pay royalties. That was the basis. I don't know if that necessarily is how BSPB insists on how it's done. So yeah, a bit out of my depth to give a complete answer.
Aniso would like to see something that recognises high rainfall at harvest and varietal difference to sprouting susceptibility. A very wet harvest period and a variety very susceptible to sprouting can decimate both yield and quality. In the already wet West, I'm up for the hotter and drier scenario. Any comments on that? What's the agreement?
Keep that in mind.
How do we translate information from models into practical field decision making? I assume that would be for you, Anissa.
That's a good question. I think at first I need to make sure that, you know, the models are like accurate and up to date, and until they've got like the latest years with the varied climate in that, I don't feel comfortable. But assuming all that goes well, I'm sure there's ways to incorporate that in. Go ahead.
Thank you. Paul, do you know the mechanism of BYDV tolerance?
No, the genetics is different in wheat and barley, as you'd expect. The wheat one is quite well characterised, and they understand the mechanism. The mechanism in barley is a little bit more vague. They don't quite know how it works. Something that's worth noting is that the genetics in the wheat has been overcome in certain parts of the world, which is why RAGT advised using an insecticide with Wolverine, because there is a possibility that that could be overcome, that resistance could be overcome.
Thank you. Bastian, did you write this one? Bastian, this is such a good tool. I think I saw you out there. But Paul, are we going to see a four-way comparison included in the RL as per the Danish?
It's interesting. I had a meeting with the CEO of BSPB yesterday and the director of cereals and oilseeds, and we did discuss whether we would need to introduce blends into the RL. Obviously, it would only be as a control, because there are an infinite number of blends you could have, but it is something that we are considering. I don't think you see it in the next couple of years, but perhaps it's certainly something that if it starts to be taken up on farm, we could certainly see that introduced into the RL as a control rather than as a test specifically.
Bastian, do the most resistant varieties perform better when they're in the blends with the disease-susceptible varieties? And if so, should we not be using the most resistant varieties?
I think this kind of goes back to this caveat that the data that we use to suggest our best mixes, we haven't really tested that, so I'm not sure if Ambro kind of highlighted the additional yield that the siskin Xtaze had over the individual or over the strays, but that was 10%, if I believe, on average, higher than the individual ones. I don't think so. No, for sure, the current tool would not predict such a big response. So what the tool would do is would take the average yield of siskin and then of Xtaze, and it would suggest that the mixture would produce something in between, and therefore it completely misses out the dynamics that happen in mixtures, and therefore that's the main limitation. So I would say that I certainly wouldn't make those predictions. That it's difficult to say. I think really what I would like for this tool to be is the inspiration to start trying blends on farm. And I'd be very excited to see if a particular blend was picked and included in many locations, just like the Danish RL has done, because that's when you see, robust data from multiple locations being put to the test.
Finally, to close off the session, Bastian, do you think there's any hope that the breeders, in your opinion, will get behind use of blends?
Can I pass that one on to Paul?
I suspect blends will become more common. I'm not sure how much the breeders like them. I think it just complicates their process, and certainly BSPB in terms of collecting royalties, it gives them a big headache. I don't think they'll ever be popular with the breeders, but I'm sure they will be taken up more on farm as we see the toolbox of chemistry decline, this push towards IPM, that they're going to be one of the solutions in certain circumstances, I'm sure.
Brilliant. Thank you all for another brilliant session. Really appreciate that, and all the hard work that goes into producing the information and knowledge that you shared today. So now that leads us into lunchtime. I can almost feel the stomachs rumbling. Where the exhibition space is, there's going to be food served in there. There's seating all in the foyer area and everywhere, so you kind of spread out and kind of take some time to yourself or to chat to others. Reminder that the exhibition space is there to be used, so go around there and have a chat to those people as well. We're looking to be sat down back in our seats at 2:30. If you're at home, enjoy your sandwiches at home, and we'll see you at 2:30. Thank you.